Alrighty. So thank you everyone for coming to our modeling revision meeting. I know the date says 4/23rd, but today's meeting is going to be a little bit more CADing focused, as in how are we going to actually incorporate our mentor feedback into our actual designs. So if you guys haven't known by now, we're done with the annotated blueprint. I sent it to our mentor leaders rehab robots, and they were fine with it, and they're working on little tiny details. And this is where we come in. Our company that's helping us build our actual device already knows 80% of the general gist, like what type of part to order, or how much material they need, or what type of screws or what type of parts they need to order. They already know all that. What we need to focus from now on is purely from us, and that's fine-tuning our device, and we'll send them to our mentors, and they're going to look over it. They're going to put it in our design. So just letting you guys know, this is a huge step for our club. So please try to get things done on time. I know the 5-day restriction, which I'm going to go over a little bit more detailedly, it's a little bit hard on you guys, especially since the AP seasons are there. But as I said, this meeting is here to help you. Like this Sunday meeting, we don't usually do Sunday meetings like this, but I did one specifically here so that if you want to make your model revisions as we go over this meeting, you're completely free to do so, because today I'm going to go over how to revise each and every single model. Now, just to kind of give you guys as like a breath taker, not all models are going to have significant editing. Like not every single part is going to have a lot of edits and revisions. Most of them are kind of little minor details, but there is for all parts. So, please try to pay attention, at least for your part. Alrighty, so just a quick due date. Notice and just important due dates. Please finish your 3D modeling revisions by the 28th. Now, I just said 28th, but our ultimate end goal is by April 30th. It's a little bit difficult for us that our mentor suddenly gave us this due date, but it is what we have to work with. It's just crunch time. It's just something that happens all the time throughout our lives. So by April 30th, please turn in your model revisions. If you can't, what I need to do is either ask one of the group leaders or someone else to do it, and asking another person to take another person's model and revising it like the day before it's due, it's a little bit hard for me to do. So please try everyone to, be accountable for the parts they're assigned with. So here's just the name of the parts with the names of the students with the parts in the final design. Now, if your name isn't in here, that's perfectly fine. Someone else is going to take on F1 anyways, and F1 is going to need a modeler and a reviser, as well as some of the parts over here. Like Lyndon couldn't make it into this meeting, so there's going to be basically spots open. And especially with Lyndon's part, wrist 1, that has a lot of edits. So for someone probably from wrist 1 or the wrist or the fingers group can help out Lyndon and, kind of just make sure that the work you guys get is a little bit more manageable. So here's our 3D modeling revisions. Wrist 1. Now, first of all, there's going to be a lot of edits for wrist 1. But this is kind of like our final model. Obviously, there's a lot of things. So let me kind of go over them a little bit more detailedly. So first of all, we need friction pads. These friction pads are supposed to keep the device from sliding off. So when you place these pads, we probably put these little plastic holes to indicate where the friction pads have to be located in. So for example, there needs to be a friction pad located over here, over here, over here, over here, 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 and here. And then there's this one giant one over here. That's to kind of uphold so that the cylinder that's going to be holding all the weight isn't just floating, that there's something actually keep connecting it to the ground. So let me quickly go over that with you. I'm going to open up Autodesk, and you guys are going to see me modeling this in real time. So the person's base model is going to be Lyndon's. Now, that doesn't mean Lyndon always has to revise it. Because everyone's model is in a drive folder, anyone can revise it. And that's what I'm going to try to do with people who don't have parts, and especially this part, because there's just so much to do. So everybody can see my 3D model, right?
Yes.
Okay, perfect. So now I'm gonna minimize you guys so that I can use Autodesk. So first of all, if you guys don't have this PowerPoint open, I significantly encourage you guys to do so. I'm gonna quickly grab a link and post it in Zoom chat so that you guys can kind of look over this with me. But don't worry, I'm also gonna post this on the Discord. So let me know if you can see it. But yeah, I'm gonna also post this on Discord. All right, so you can look at the slides with me, but it's not exactly necessary. If you're just following what I'm doing, that's perfectly fine too. Okay, so very first thing for wrist 1 is to come up with these friction paths. Now, if you look at the dimensions over here, I put very specific dimensions. So let's kind of do that real quick. Start 3D sketch over here. We need to create a rectangle. And we probably need 3 parts. There we go. And I guess it's going to take a little more time processing since I am running Zoom at the same time. Okay. So if you guys can kind of look through the pictures, you guys can kind of see the measurements I put in. So let me just kind of quickly go over them with you. I'm going to have to minimize this so that I don't get hindered by the Zoom thing. Okay, so let me quickly cancel that. So first of all, this distance, as I wrote it down, is 0.5. And since I want all of these to be equidistant from each other, all of these are going to be 0.5. That's the first thing you do. You draw any type of square and you make sure, or a rectangle, I should say, and you make sure that the distance from here to here is 0.5, here to here is 0.5, and here to here is 0.5. Now, all you have to do from here is just draw for circles. It doesn't have to be a specific length, but it just has to be a circle. Now, if you look at the dimension sheet, it tells you that all of these circles also have to be 0.5. That's pretty simple. All you do is just click on it, just write down 0.5. This over here, just write down 0.5. So over here, 0.5. This over here, 0.5. That's pretty much all to it. Now, since I made these in solid lines and not construction lines, you're supposed to make these lines construction lines. Now, just to recatch you on how to do a construction line, you just have to click on it and click on this tool over here, this thing. And if you hover over it, it tells you construction. So perfect. Also make these construction lines. And there you go. Now, one other thing I asked you was to draw a circle. Now, I didn't exactly specify how to place a circle, but you can tell where by looking at this too. You guys kind of see like a line in between. So if you guys see a rectangle, see this rectangle over here, there's going to be a line. I'm just going to do this in construction from one edge to another edge. That's just a line that completes the outer rectangle. It's not the inner rectangle, but the outer, because remember, there's 2 rectangles. There's one here and one outside. All you have to do is make this circle, and you use it by using this constraint tool over here. All you have to do is click on the circle and this point. And that's pretty much it. You have your inner circle done. Now what you have to do is create these little squares. Now, you'll need these squares, so please pay attention. These are pretty important. So first click on the rectangle tool, click on here. And if you actually hover through this line, there's going to be a little line that lights up. You guys kind of see that? It like glows up. And you're supposed to drag your mouse until you see that point. Oh, yeah, you kind of see that? And now you see how there's like a green point instead of just like a regular point. It's like highlighted. That's what you want to do. And then, well, just any length is fine. And then what I want you to do is just measure this. Now it's just going to give you 2 inches, but that's perfectly fine. I want you to do this also 2 inches. Now you can manually type in 2, but as I've shown you in videos before, you can just click on this part as well. Oh, it's because yeah, there we go. And same with over here. Just to kind of recap you on how to get that sweep point. And you guys kind of see that green line light up? All you have to do is just kind of like trace it and place it on the dot. There you go. You see how, okay, let me kind of show you what I mean. You see how when I was hovering through, let me kind of show you exact steps how to do it. So first there's this green line, but if you get close to it and you kind of trace through it, I'm not saying on the actual line, but if you go close to it and trace through it, a black line shows up, and that's when you know how it's correct. And then it's just, you know, okay, let me do that again. It's not looking so clean. First point over here, second point over here. There we go. It's a little bit nicer. Dimensions over here is, dimension over here is going to be 2 inches, of course. This has also got to, dimension from this point to this point has also got to be 2 inches. Perfect. Now that we have that, I want you to draw 2 circles. Now, it's a little bit hard to grasp where the exact circle needs to be, but it's just kind of like feeling. When you kind of go through the middle zone of the square, it kind of like locks you on. Like when you just browse and you just kind of land onto the middle, or what it seems like the middle, it will kind of lock you on. And that's what you have to do. Same with over here. There's no specific area, but when you lock it on at a specific angle, it kind of gives you the middle by itself. Now, if you see in the sheet, that also gives you 0.5 inches. So let's do that. This thing has also got to be 0.5 inches. Okay. And since we want to actually extrude this, let's turn this back into solid lines and not just construction lines. Okay, so now that there's this, there's just one more hole you need to drive. Now, I want you to click arc through center point, and I want you to grasp onto this point, grasp onto the center of this circle, and go all the way through this circle. Okay, what's the problem here? Oh, it's because this square is not drawn properly. Let's see, okay. Sometimes problems like this will occur, and you know, that's just the technicality of this software. It can't be perfect all the time. There we go. 2 inches, and this has got to be 2 inches. There we go, perfect. Now if we draw 2 circles over here, just, oh, okay. That's probably why. Okay, so it's a little bit helpful to zoom out because here's the thing. When it locks onto here or here, you guys kind of don't know exactly. So let me make this circle a little bit better so you guys know what I'm talking about. This circle has to be in the exact same line of the center this circle is in, so it makes a good, nice arc. You guys kind of see how this is the middle and not this? It might look like the middle, but as you guys can see, it's kind of like off. That's why you kind of want to check with your eyes over here that this is the middle. That's the problem. All right. So after you guys do that, let me just cancel out of these and make these into solid lines. All you have to do is just draw an arc from here to there. Now it's perfect. And then from there, all you have to do is just draw another hole over here and make that into 0.5 inches. And you want to make this into a non-construction line. There you go. Now, after you have that, you're essentially done. I want you to click Finish Sketch. And all you have to do, if everything works well, is to extrude these, if the computer wants to. There we go. Now, these are going to be friction pads. So I don't think friction pads are this thick. I mean, I'm sure you can create them this thick, but it's not going to be. just put it to 0.1 or something like 0.2. Let's actually set it to 0.1 since that's the measure I used. Perfect. And there you go. That's one part of RISC-1. Now, since Lyndon created this model, someone else is probably going to have to revise this, especially because there's a lot of parts to revising RISC-1. So this is going to be one part. So one of you guys is going to have to do what I've just done. Is everyone kind of clear with that? People in the RISC group, any questions? Alrighty, cool. Let's go over the next part. So we're not exactly going to move on yet because there's going to be additional edits to do. Okay, so now we have to drill through holes. Now, why do we drill through holes? Well, it's just a little bit more efficient. One of the feedbacks our mentors gave us was that, this whole bulk of a sheet metal, it's fine, but usually in the mechanical area of this world, you just kind of have to use what's the word I'm looking for? Conserve parts, basically, conserve material. Just because it's like it's just like common courtesy, I guess. So first of all, you want to draw an arc from here, and hopefully it latches on. You kind of see that circle from before. It wasn't there before, but only because you did the other part, it kind of shows up. Now, if the circle doesn't show up, that's fine, because you can just go through the steps of RISC-1. So if you're watching this video later and you're wondering how to get this circle, as I said before, just rewind the video back and you just got to draw a square, and that's all you have to do. So let's draw an arc from here. Okay, actually, let me just demo quickly so that if you guys are watching this later, you can do it. Okay, so let's say you don't have this circle. Then all you have to do is just do a simple rectangle from here to here and just any point. This is going to be equal 2 inches always, and this has got to be equal to 2 inches. All you have to do is just draw a circle. That's the center of it, and draw it into 0.5 inches. Same with here. All you have to do is just draw that, draw that, draw that. 2 inches always. That, you just got to make it equal to 2 inches. Oh, that's not exactly what I want. That's it's different. There we go. That's the 2 inches I want. You guys kind of see how it's kind of like slanted? That actually does make a difference. So make sure even with the dimensions, they look right, basically. And of course, as I said, this center, oops, you got to follow this center and just draw it on the circle here. There you go. Now I'm going to make everything construction lines. Oops, I didn't mean to do that, but we can just redo it. There we go. Now that we have that done, I just want you to draw your arc again from here to here. Now let's also make that into a construction line. From here, I want you to take a little bit more of a cautionary step when you're doing this. I want you to draw a rectangle. 1 point here, 1 point here, and a point there. Now let's also make this into a construction line. First of all, I want you to make sure that the distance from this line, so let's actually quickly draw that line from here to here, just like the center of everything. I want you to make sure that the distance from here to here is equal to the distance from that. So it's just kind of like, neater looking. It's symmetrical. Now, I don't know why I have this circle here, but, oh, maybe it's from the back. Nope, I guess not. It's just there. It's probably just a highlight from what I had before, because Autodesk usually highlights dimensions you've created before. So just like a thing they do. Oops, that's not what I meant to do. Okay, so now that you have this done, I want you to create a line from here to here and here to here. And these can actually be, actually, no, let's just set that to construction lines as well. just so that it's a little bit more organized. So now that we have this done, we can draw our holes, but actually not just yet. We have to do something real quick. This has to be 1.837. That has to be 6.5. Okay. And this point over here, let's actually draw a line so that you guys can see it. It can actually select that line. There you go. The line from here to here, oh, it's going to be 8.43. Alrighty, perfect. And then distance from here to here, let's see if we can adjust that. No, we can't. Okay, so there's a constraint error. Something's over constraining this. Let's just go back to the drawing. 6.5, 6.5. Okay, so these are too big. I think that's because that arch is not exactly, yeah, it's not exactly parallel. So in that case, just draw another arch. I mean, we already have these lines anyways, so we don't exactly need this arch, but it's just a little bit, it's better for reference. But now that we have that, and let me just make this into a construction line. There we go. Just draw any arc from this line to that line. And then what I want you to do is make sure that the dimensions from here to here is equal to 6.5. There we go. Now it's perfect. So now that we have that done, turn that into a construction line, and then just trace those lines from here to here, here to there, here to here, and there to here. And then these arcs, all you have to do is just redraw them. There. And here to there. Perfect. This is exactly what I'm looking for. I know I kind of over-explained with this whole arch. You don't actually need this arch. You can just kind of delete it. You don't even have to do these squares or these circles. All you have to do is just get this line that goes from this edge of the square to this center. So you'll have to create the squares, but you won't need the circles. Let me delete those so that you guys can see a little bit better. Oh, I guess I just can't delete them. Oh, it's probably because they're just, yeah. But basically all you have to do is just draw these squares, get the lines, draw the arch, get the 6.5. And since we made this equal to each other, if you actually calculate the distance between this point and that point, it's also going to give you 6.5. So that's it. After you do that, just finish your sketch, and I want you to do extrude. But here's the thing. Instead of extruding it outwards, for example, just 5 inches outwards like this, I want you to actually go backwards. And instead of choosing like a number like 3 to check if it actually goes all through, just press this button over here, through all. And once you click that, boom, there's a hole. Now, that's a second part on how to revise this part. It's different from the circles we did. Yeah, it's fine, Jeho. Just look at the recording later. So the putting like the friction pads and drilling the holes out are 2 different tasks, as in there's going to be 2 different people that handle it. Now, here's the third task, and this is the most annoying one. So whoever gets this, you know, you just kind of have to do it. There's no better way to, I guess, sugarcoat it, but it is kind of a little bit annoying. So first of all, I want you to create a line, excuse me, from here to there. And it'll kind of light up for you when you kind of get close to it. Then I want you to draw another line, but just draw it anywhere on the circle. It doesn't really matter. There we go. And then here's the important part. I want you to make it so that that's 7 degrees. So the difference between here to here is 7 degrees. And same with here, from here to here, 7 degrees. Now that's done, I want you to create another line. I know it's a little bit time consuming and not much real effort, but our mentors really wanted these lines, so, what can we do? Also make this from here to here, 15 degrees. From here to here, 15 degrees. I meant to type in 15. There we go. And then another line. I hope you guys can kind of see the pattern we're going at. We're going 7, 15, 7, 15. So according to the pattern, this is going to be 7. According to the pattern, this is also going to be 7. Now, how many of these do you need per side? You need 3. Let me actually do all 3 so that you guys know exactly what to do. So like I said, following the pattern, this is going to be 15 degrees. And from here to here is also going to be 15 degrees. From there, you need the last final one of 7 degrees. Oops, just kind of locked on. From here to here. There we go. And from here to here. And the difference between these two are going to be 7 degrees. Oop. Okay, it's probably because I draw too many lines. If that happens, just redraw it. It's just a thing within Autodesk. They like to kind of just group lines together, but sometimes they won't do that. So, it's just something you gotta do. Just, I guess, a minor technical difficulty. There we go. Now that we have that done, here comes a little bit more of the frustrating part. I want you to draw 2 arcs. A big one that just goes from here to here, and a smaller one that goes from this point to any point on this line. From here, I want you to do from here to here is going to be 0.5 inches. If you check on the presentation, it tells you that. So now that we have that done, here comes a little bit of an annoying part. You have to draw arches from here and there. And you have to do that with every single arch. And of course, you also have to draw lines from here and here. And that's the part we're going to cut out. And you have to repeat that for every single one of these. I'll just kind of go over them quickly so you guys can just see the final result. But this is the most simple part of this edit, so you really shouldn't have much trouble with it. All you do is just draw arcs. From here to there. And one last one. And then all you have to do is just draw the lines between each. There we go. And done. Okay. So now finish your sketch. And here comes the fruit of your labor. All you have to do is just extrude them backwards, the second sign, and click through all. And okay. And there you go. 3 people are going to revise this one piece. That's how important it is. So that's risk 1 for you. I'm going to post this recording later. So if you're assigned one of these, please look back through these videos, but don't worry. Most of them are going to be easy. So I know this part by itself may look really complicated, but that's why I'm splitting it into 3 so that your roles are a little bit more divided. So don't worry too much about it. Okay, now let's move on to risk 2. Now, remember how I said some parts you're going to have a lot of edits, some parts you're not going to have much? Here's one really good example. Risk 2, we're going to use Junso Yang's. Okay. Essentially, all you have to do is just make this smaller. And I made this edit easier. So just click on this line and it says 2 inches. Now, if you look in the diagram or the slideshow I posted, it says I want it 1 inch. Well, you're asking, well, how do I delete a part? Like, do I need to re-CAD every single one of these? And I'm saying no. Just press the extrusion that resulted in this getting long. So you see how like extrusions will highlight it? I want you to click on extrusion 2 because that's the one that highlighted this. Now, if you double click on extrusion 2, it actually shows you how many inches you did. It shows you 2 inches. So let me kind of show you that again, because this part is going to save you a lot of time. Click on extrusion 2 because that highlights the part we want to edit. Click on that and just type in 1 instead, and boom. Oh, there we go. Actually, let's kind of go over this again so you guys don't freak out when there's an error sign. Double click on extrusion 2, click on 1, press OK. Look, it's going to give you this thing. Edit extrude feature failed. Just click accept, and here you go. It didn't fail, it worked. It worked perfectly. And all of Junso's holes that he made are perfectly there. So that's all you have to do for risk 2. Someone's probably going to get this job, and trust me, it's going to be a real breeze. Now going over risk 3. That one's also simple too. We're using Cyrus's part. All you have to do with this one is just make it 1 inch shorter. So how do I exactly make this 1 inch shorter? Because as you guys can see, there's not a specific part that points toward this rectangle. It's simple. Just draw a rectangle again. Draw it from here to here to here. And finish your sketch. You're already done. All you have to do is just extrude it backwards 1 inches. That's all there is. So let me kind of show you again because I kind of went a little fast. You start your sketch on this surface and you want to trace out this rectangle. You get the point, and a point there. Press finish sketch. That's all the sketch you need, just that one rectangle. Just extrude it backwards by using this key over here. And don't press through all because then it's just going to drill everything. Just type in 1 and there you go. It's done. That's all there is to it for wrist 3. So hopefully you guys can do that without any trouble. Now, for wrist 4, that was done by Michael Cernius. Over here, you guys might be wondering, how do I just lob off this part? Because one of the feedback our mentors gave us was, how do I just, he wanted us to get rid of this because, you know, there's obvious ways to improve a device. There's going to be drawbacks between, there's basically a scale, a balance, I should say, between technical features versus materials. And one of the feedback our doctors gave us was that this adjustability wasn't as worth it as our effort due to the fact that we don't need all that space in the first place, and you don't really have to tighten it like super tightly on the patient. So you might be asking, how do I get rid of this thing? Because as you guys can see, and props to Michael for doing such a great job on this, having really nice smooth features, you guys might be wondering, how do I just lob this part off? Well, let me kind of show you. There's a really easy way. All you have to do is just click on this part and just draw a rectangle from this point and honestly, any point on this surface, big enough to cover everything. You see how it's big enough to cover this entire thing? That's all you have to do. It's just that. Just draw one rectangle that's big enough to cover this surface right over here. That surface right there. You see how that's inside the rectangle? That's all you got to do. And then I want you to extrude this, but instead backwards and through. Oh, wrong button. Yeah, backwards and through. And boom, it's gone. And there is all there is to it. All you have to do is just draw a rectangle big enough to cover everything and just extrude the rectangle backwards through all. And that's it.
I also need to try to make sure that curved bit has the proper measurements
Oh
as
yeah,
they
for
are on
sure.
the actual annotated blueprint, because that's kind of eyeballed.
Oh,
This was
okay.
just the first version, but
Oh,
with the exact same circle dimensions, we could kind of do the same thing, just more specifically.
right, right.
So
Oh,
it's
and
like at 0.282 inches instead of 0.25, which is what I
uh-huh.
wanted to get.
Oh, okay. Yeah. So
So if you could
Michael just
show
made
how to do that, that would be cool, because I don't know, but
make
I
what?
I could figure it out. Show how to make sure that that coordinate would be exact.
Okay. Well, okay. Well, which exact coordinate are you talking about? And why is my mouse stuck? Okay. Oh, it's still stuck.
Oh, so I mean,
Oh,
for the actual bit that curves in, to
uh-huh.
create that, I just extruded a circle
Okay.
into it, so like
Uh-huh.
backwards, but I didn't like measure it up completely because I kind of just drew it on and eyeballed it to 0 point
Okay.
some. I don't actually,
It's fine.
like that.
I'll kind of
So could
like
you explain how to actually set that up properly?
yeah.
Or
But give me 1 second. My mouse is stuck to the model, and I honestly
oh
have no
boy,
idea how this happened. It
try
kind of
uh
sucks. Let me just kind of tap out. Nope, still stuck.
yeah,
Let me just close my Autodesk Inventor.
okay.
It's a small technical issue.
Now, I mean, the way I could do it, that I could have done that would be to like uh define the measurements like you would with all the other shapes, but I didn't do that for the circle. I mean, I guess I don't really need you to explain it now that I think about doing it that way. So I guess it's okay. I just need to create a 2D sketch with fine measurements to make sure it's the right size.
Yeah. And the circle part was an extra thing you did. Like it wasn't part of the
Yeah,
necessary requirement. So
original
just being
design.
yeah,
Yes.
just being
I
there
just
is
thought it would look
perfectly
good.
fine. Yeah.
Okay.
Let me restart my Autodesk because it just crashed on me. But Michael made a really great point, and that's revising your dimensions. Like if you obviously know something's off with your model, it's a really good time to revise it. So let me quickly restart my Autodesk. Alrighty, which part were we looking at? Risk 4. Okay, so Michael, do you got it, or do you want me to show you how to make it a little bit more thicker, the circle?
Yeah, I've got it.
Alrighty. Okay, so that was risk 4. Now let's go over risk 1, the dreaded part we've been struggling for quite a long time. Let me just get up Autodesk Inventor 2021. Okay, so if you guys are wondering what happened with risk finger 1, it's a little bit complicated. Our patient, Mr. Daniel, he has a stuck hand, like he can't really open it that well. So we need to make some sort of revision in the device where he can just slide it through. Here's like a pen real quick. He just needs to just slide it through the actual device. So one of our device that has to account for it, excuse me, is F1. Let me share my screen with you guys. Wow, everything is really slow on my computer right now. It's not that good. Okay, but let me kind of quickly go over the features of F1. You guys don't exactly have to CAD it again because it's already there. But let me just kind of go over with you why it was built the way it is. So first of all, you just need a line from the top to bottom. You need a small line over here that accounts for the hole. You need one line in the midsection. And you need one in there. Yep. I should kind of move this over here. It's a little bit too far. And one smaller one over here. Now, the reason why I didn't want one of you guys to just solve this problem was that it's definitely a hard problem to solve. So I kind of just asked the help of our mentors. But as you guys can see, it's a little bit more of an ergonomic shape, as in it's a little bit easier to hold in than just like a solid chunk of rod, like a cylinder, basically. So once I get this done, let me kind of just show you on the functionality. It's going to be a line. There we go. Perfect. So as you guys can see, we have like a little rounded point. You know how like those jousting spears, they have like a pointed edge? It's kind of like that, but we just lobbed off the pointy edge so that it's a little bit more, you know, nicer looking, I guess, a little bit space efficient. So I want to get all of these, and I want to make this into 180 degrees, rotating around. Oops. Oh, looks like I got to choose a line first. Or I guess I could just, do I really need to do this automatically? Oh, it's because that's connected. Okay, well, it was allowed Z sketch in the first place, so I kind of get what it means. Okay. So just redraw a line if you have to. But again, as I said, you guys probably won't be catting this, but you know, just in case you guys want to try it out. Oh, still no line. Okay. Well, let me just redo this sketch then. Gotta turn that into a construction line. Oh, am I not in stretch mode? There we go. Oh, man, Autodesk is really acting up for me today. Not a good sign. There we go. Yeah, there we go. Now it's more clean and nicely done so that the program won't freak out. Okay, so this isn't the exact model we have, but this is a pretty good replica of it. You guys see how this is like a dome, almost like a pointed edge without like with the tip cut off. It's kind of like that. Since this is like a general dome, or like I should say like since this part over here, this part and that part, you see how it's kind of like a rounded edge, so that patients can just insert it in. Let me kind of show you with this one thing I have. So like this is a liquid container for like one of those energy drinks. And basically the patient's just gonna push their hand in like that. Like it's just gonna, they're just gonna help make the device kind of just open their hand for them. Because think about it, if my hand is stuck, I need like a pointed edge to help it open it, right? It's kind of like that. It's just kind of like, you know, they'll kind of force their way in and kind of open their hand if they can't open it. So that's the reason for this weird looking oval shape. And for over here, why I made it this way, our mentors just kind of suggested that this should be a little bit more comfortable, since a lot of these patients, or at least Mr. Daniel, he's a former comatose patient, and he's going through a lot of rehabs and things like that, or hemiplegia. And he's probably going to use this a lot. He was really excited about using our device, and he's just like a general outgoing guy, ambitious. He's going to use it a lot, and so with a lot of rehabilitation patients. We don't want to make this device so bulky so that whenever they use it, it's like painful or uncomfortable. We kind of want to minimize that. They're already, you know, in such a condition. So little design changes like that really do help. And this pertains to one of the things I said earlier in the meeting about how I said, you know, now this is actually going to be reproduced and produce and help people. We got to pay a little bit more attention to it. This is just like one of those things. Like someone's going to use this for hours and hours and hours if they really do like it, of course. But and if they do, we want to try with our absolute best so that the patient who's using this has 0 to no difficulty at all. So just kind of putting that out to you guys. This is just like an example of what we have to look out for. So that's the general gist of Fingers 1. If you guys want to recreate it perfectly, that's up to you. if you're saying, well, Jacob, I really want to give this model a try, 100% I'm open to it, because the model right now that I'm using, it's what I created. But if you guys want to recreate it real quick and send it to me because you kind of want your part to be there on the device, like especially the students who didn't make it to the final part, this is like a great chance to just tell me like, hey, Jacob, I really want like my part to be in the medical device. Is there anything I can do? This is one really great example of the thing you can do. And especially because there's separate parts to this design, like the bottom part where you have to draw like an oval and a pin. That part's easy because that's just, manipulating with just measurements. But if you want your part to be on the device, this is a great example of what to do. Now quickly going over F3. This is Ethan Grimmager's part. Let me quickly open F3. There we go. So as I said, this is also posted on the Google Slides, but essentially all you have to do is just draw one line from here to there. That's pretty much it. Well, I shouldn't say that's pretty much it because there's a little bit of a measuring to do. This picture is a little bit hard to see, so let me pull up a better picture. There we go. The distance from here to here, and I want you to drag it out, it's going to be 0.221. And the distance from here to here is also going to be 0.221. Now, be careful when you edit this dimension. Let me kind of show you what I'm talking about. If you just draw that, you can get multiple dimensions. Like, for example, if I just drew it here and here, or if I just drew it from this point, oh, it's selecting something else. Doing this point and that point, sometimes it'll give you this. You see how this is different from what he just had? So, watch out for how to actually get these measurements because obviously, there we go. Oh man, why is Autodesk so... Okay. It really does act up sometimes. There we go. You see how this is perpendicular to the x-axis over here? But if I kind of just drag the point from here and I just physically drag it, it's now different. That's what I'm trying to say. That needs to be 0.221. And of course, since this is just out of bounds, just click on that point and this point, and there you go. I want you to make sure that this point from here to here is also 0.221. There you go. And I just want you to draw a line that goes from here and line goes from there. And press OK. There you go. And all you have to do is just extrude this backwards all the way through. That's it. Oh, there is actually one more thing. Sorry about that. I just remembered on top of my head. And this is going to be separate. So one person, like let's say Robert's going to do it unto this point, and let's say Junso is now going to take on. I want you to just press on this, and then we're going to do a quick arc at the center point. If you kind of like drag your mouse point around the line, it's going to lock on. You see how it's like yellow right now? But if I like go to the middle, it suddenly turns green. That's just kind of like a software kind of telling you. It's just like a convenience where it's like, hey, this is a center point. There you go. And then I want you to draw that line one more time just so that Autodesk doesn't freak out. And all I want to do is just extrude it and make it 0.5 inches. And boom, your part's done. So 2 people are going to edit this part. 2 people. Wrist 1, there's going to be 3 people. Fingers 3, there's going to be 2 people. Now, you guys might be asking what happened to fingers 2. Well, one of the feedbacks our mentors gave us was to remove fingers 2 because one of our mentors didn't like that we're fiddling with safety mechanisms. So one of our mentors is really passionate. He's part of the Leaders Rehab Robots company, and he's been doing this for quite a long time. Their company has been really successful, and they kind of want to really help us with this. They're really happy to meet this other doctor, Dr. Kova, as well, and they're really outgoing with this project. And one of the things they kind of want to cover up for us, kind of like they want to take in charge, is safety mechanisms and regulations of like medical devices. Because remember, we're not going to like sell these machines, but at the end of the day, this is a professional model where this is actually going to be a medical device that helps people. And our mentors didn't really want us to worry about like safety mechanisms, because at the end of the day, we're really not that experienced to deal with those things. Like, we've never actually treated patients before, and we don't know like FTC regulations with medical devices and like electronics and things like that. You'd probably just need like a lawyer. And that part is the part they want to help us with. The part where students really can't do it, that's the part they want to like step in and kind of help us with it. So don't worry about safety mechanisms. Obviously, don't create something that's too unrealistic. You know, that's just kind of like common sense. But if you're wondering like, oh shoot, is this one revision gonna like potentially endanger the patient? Don't worry about that. That part our mentor is gonna for sure support it for us. So do not worry about that, please. I don't want you guys to hesitate editing things because you guys are afraid it might hurt the patient. Please don't worry about that part. Just do it as you want. I'm trying to tell you guys that you guys are free to do whatever you want with these revisions, but just keep in mind that there's someone always going to be helping us with this process. So don't feel too overwhelmed. So now that we have gone over all our parts, here's just kind of like a complete assembly. Now, just because this is here doesn't mean you guys can not revise your models. This, again, as you guys can see over here in this pale white model, is a very, very, very basic model of what you have to accomplish. Basically, this is not polished at all. You guys need to put a little bit more revisions and effort so that this looks a little bit nicer. Here's some pictures I took of it, but this is mainly for our mentors. So let me actually kind of show you that assembly so that you guys can have a general idea. So over here, it's called Complete Assembly, and I think you guys are gonna like what you'll see. Okay, so this is our final model. As you guys can see, it's pretty basic, as in these edges need to be round up. This point should be round up. This point over here, there's screw holes here, but there's no screw holes there. There's the screw holes here don't match these, and there should probably be something rounded off. And this over here should probably be rounded off as well. And maybe I should also edit the length so that this thing over here has some clearance space. Things like that. That's the part we're actually gonna spend the time. I want you guys to start figuring out minor details that you guys can revise. Because as I said, we're done with 80% of the general idea of how the device works. Now it's the time for fine tuning to make this device professional looking and just a little bit more usable, I guess. So as you guys can see, if you're wondering, oh, I didn't need to press that. But anyways, if you guys are wondering how the patients are actually going to use this device, let me kind of show you what I mean. If I delete this, I should be able to move this. Perfect. So first of all, these hand covers are going to be entirely separate from this device. There's probably going to be a magnet. That's what our mentor was talking about, having like a really high, a little bit of a strong magnet. Like my mouse has one of those things too, but it's just like a magnet where it just kind of like sticks through. So first of all, oops, this is going to be the general gist of our device, this part over here. The patient's going to put their arm through that circular point and grasp onto these two parts. They're going to grab onto it. So like this water bottle, they're just going to grab onto it like that. They're just going to grab onto it. And after they grab onto it, they're obviously going to have another hand. And of course, if they can't do that, a doctor like Dr. Kova can help us. But after they put their hand in, they're going to put this thing over here. And obviously with this thing, they're also going to put it down like that. And boom, our device is ready to be used. You see how there's a axle over here underneath? See how kind of there's like a pointed edge over there? That shows you the rotation. So when these two things rotate like this, when it opens up, that's how the device is going to work. Now, this part over here is also going to move and lock on. That's why these homes are here, or these pavements, I should say, so that it can lock into one place. So that when you're using this device, you can lock it into one place, lock into another, lock it into here, lock it into there, little things like that. And of course, we also put those locking mechanisms here because what if you're left-handed and you want to lock those points too. And of course, you can always take these points off, but I hope you guys understand by now how this mechanism works. These over here are going to open out, and when it opens out, it's going to stretch my hand like that, open. So with that said, that's kind of like the general model. I actually put that inside the file so that you guys can see it, but please don't think as we're already done. We definitely need more polished models. So now that's done, let's kind of just go over quick announcements. So here's where you turn the thing in. I posted this Google slide on Google and Discord, so you guys can always just, click on this link. So please turn in your revised models at a folder called Please Upload Revised Files. The folder is literally called that. It's hard to miss. Now, if you are stuck or need help, one way you can find help is by finding the finished models, the one I just showed you, on the expected models folder. And that's for reference only, okay? Don't copy and paste it. I kind of want you guys to go through that process. And if you need help, you can always contact me or the group leaders. They know what they're doing, so they can always help you. Now, just a quick reminder, we need these models done by April 30th. Now, because I'm splitting up all these roles, it's not going to take a long time. It's only going to be a couple people. But let me actually assign those roles quickly. For Wrist 1, Lyndon isn't here, but is there anyone who wants to help out Lyndon right now? I'm sure Lyndon would be fine doing everything alone, but is there anyone who wants to help?
I can help him.
Okay. Wrist 2, Junso, you got that. That's just one simple part. Cyrus, you get wrist 3. Obviously, Michael, you can do wrist 4. F1, I'm going to leave this out to everyone. If you want your part to be on the medical device, this is your chance to shine. Perfect opportunity here. Anyone can do F1. F2, or I mean F3, Ethan Grimminger can just do this part. Who wants to help out Ethan? Actually, Jake, why don't you split up?
Yeah, I
with
can help
Ethan?
out.
Yeah. So you can do these. Okay. So yeah, that's pretty much it. Robert, you're free to help out anyone or tackle on F1.
Okay.
And let's see. Yeah, that's pretty much it. So with that said, you guys are free to go. Thank you very much for coming to a Sunday meeting. I know not all of you guys can make it, but I'm really appreciative that you guys could come here. So yeah, you guys are free to go if you don't have any questions. Take care.